Hi, today we're going to learn how to add tool paths to files using layers. Layers were originally used in hand-drawn technical drawings to differentiate between sections of a drawing. In building plans, for instance, they would draw different parts of the building on actual layers of clear plastic. You could lift up the roof layer to see the internal walls as an example. In CAD programs, you can select which layer you want to draw something on, and later you can select or make the whole layer visible or invisible. Layers provide a very easy way to assign specific tool paths to various features in your drawings. To start off, let's open a drawing. This drawing has multiple layers. A quick way to inspect the layers in a job is to use the Select by Layer button here, just across from the Selection tool. It quickly shows you all the available layers that you can choose from. I see there's a layer named Text. Let's select that layer first. Because this is a single line engraving font, I want to use a V-shaped cutter to engrave along the center of the lines. As the text is selected, I can just go to the Tool Path toolbar and select Center from the options. This is very similar to the Offset toolpath, except that it cuts down the center of the line. Here I'm going to create a new tool path template for this material. I do this by selecting the tool I want to use, then click Add Template. For this template, I want it to apply to this material type, in this case melamine. So I select the checkbox here which links this tool path only to melamine. Because I want to be able to use this new template to engrave any thickness of melamine, I'm going to leave the thickness box unchecked. We have an error marker showing up here because you can't have two templates named default for the same material. So we'll need to give a unique name. Let's try V-Cutter Melamine Engraving. Once I click OK, I can then go about setting up the machining parameters to suit. The first thing I need to set is the depth. In this case, I wanted to cut 1 millimeter below the surface, so I need to make sure it is referencing the surface, and it must have 1 in the depth setting. Next, we'll select 4,000 millimeters per minute for the X and Y feed rate. And we'll set the Z feed rate for plunging at 2,500 millimeters per minute. Because the text is single lines that don't join up, we need to make sure the setting allows it to toolpath open contours. We don't need to worry about the collinear lead-in on open contours because we'll turn them off for the whole toolpath in a moment. Make sure lead-ins and lead-outs are set to none because we don't want ToolShop adding any extra lines to our text. As I mentioned, this disables lead-ins for open contours also. We set everything else to NO because we won't need pre-piercing, multiple passes, bridges, or inlays. Next, we click OK, and you will see numbers appear on each cut. This is the default cut order. Next, I'm going to do the same for the drill 6mm layer, which tells me these holes need drilling through with a 6mm diameter drill. We've covered drilling before in an earlier tutorial, so I'll just go through the settings quickly. The third layer I want to cut is named Pocket. This means I need to machine the whole area of the shapes down to a certain depth. I'll select it now. You can see that these two shapes are selected with the thicker blue line. Now, this layer doesn't specify, but it could have been named Pocket 5 millimeters deep, which would reduce any human errors. But for now, I'm relying on other documentation to know how deep. To add the Pocket tool path, I will use the Fill tool path here on the Toolpath menu. The Fill tool path has a few extra options, but it's quite logical. I'm going to use the 1/2 inch cutter for the pocket because it will also cut the border of the part as well. The job will run quicker if we can use the same tool for multiple processes. Because there aren't any existing Fill tool path templates for the 1/2 inch cutter, we need to create a new template. We need to specify the 1/2 inch cutter. We can limit the use of this template to this material only, but let's leave it available for any thickness. Then we need to give the new template a name. Let's call it 1/2 inch router, fill 10 millimeters deep, and click OK. Now we'll enter the parameters. This new template doesn't have the cutter diameter yet, so I'll enter that now at 12.7 millimeters. If I was working in standard units, then of course I would enter 0.5 inches. The rest of this section is pretty straightforward, so we'll run through them quickly. The next section is specific to pocketing. The overlap percentage is based on the cutter diameter. Usually a 10% overlap is sufficient. Minimize lifts is optional, but can save some time. Fill pattern has two options. Hatch fill will create a back and forth zigzag pattern, which removes the whole area inside the shapes. Island fill starts in the center of the shape and works towards the outside of the shape in a concentric pattern. For these shapes, we'll choose island fill. Next, we can set the number of passes in the same way as the offset tool paths. For now, we can leave it at a single pass. We aren't doing an inlay on this job, so we'll leave that turned off. The last layer in this job is the border layer. I'm going to use the 1/2 inch cutter again, so I'll create an offset template for this material. Now that we have all the tool paths added, we can move the start points. Let's select the whole part and use the arrows up here on the toolpath toolbar to move all selected lead-ins. This time I'll select the bottom left corner. Now we can run a cut order function to make sure the cuts are done in the right sequence. Now we have prepared the part for machining using engraving, pocketing, drilling, and routing. Wouldn't it be great if all of these steps could be automated? In the next tutorial, we'll learn how to use the automatic toolpath, ADP functions to do all of these steps in a few seconds. See you next time.